Hi, welcome to MegaTest. My name is Kevin. We're an appliance and biomedical test tag company based in Christchurch. We get a lot of people ask us, do I need to be tested and tagged, and why do I need to have my electrical gear inspected and tested on a regular basis? So I thought I'd take this time just to explain what your legal requirements are in the workplace and why we actually do what we do, and what reasons and what things you should be looking out for in your workplace to keep everybody safe. So MegaTest was set up to help companies comply to the New Zealand Health and Safety Work Act 2015, and predominantly around the electrical safety of equipment in the workplace. As a company, we've gone out and got ourselves qualified under the AS NZS 3760 and these other standards as well. But what we have found out in the field is that there are some companies that have just done in-house training, because under the Act you just need to be what they call competent. And we've actually taken a step forward to make sure we have the qualifications to guide people correctly and give the right advice. We see quite a lot of these in-house testing situations, or people who are not necessarily their predominant job, where they will let things slide that wouldn't necessarily comply or would fault, or be tested to the wrong time frame within the standard. As I said, we've also stepped into biomedical, so under the AS NZS 3551, we've got ourselves qualified as a company to test the medical equipment used to monitor and help patients in their recovery in a medical environment. These things could include equipment like ECG machines, scanning equipment, ultrasounds, those sort of things, the beds that a patient would lie on, etc. And even things like defibrillators, which I always find a little bit amusing in the sense that the device is designed to actually give you a shock, but I guess the reason for it is to make sure it treats the patient only at the right time and doesn't shock anybody else around them. 3003 is again a biomedical standard, and it talks about the patient and cardiac protected area or body protected areas. So places like hospitals or doctors' waiting area, doctors' rooms, where they're actually checking a patient out using the biomedical equipment under 3551. And the predominant thing around the 3003 is that the room is protected by an RCD, or the outlet is protected by an RCD or a residual current device. We also touch on 3500, which is the guide again based around the electrical area of patient care, and we also work with 3012, which is the apply and installation and construction and demolition of sites. So again, a lot of this, if that standard complies back to 3760, but there is a couple of little items under the 3012 standard which is predominant, and we use those that knowledge to guide our clients and people around to make sure that we're ticking all the boxes moving forward. As a company, we've recently stepped into thermal imaging reporting, which allows us to check out server rooms and power outlets and heavy machinery that are permanently wired. This is a non-contact inspection, but allows us to find faults that may lead to fire or electrical breakdown within a company environment. We've seen recently of a school that went up in flames because of an electrical fault. So thermal imaging would go a long way to try to see if there's an issue within a wiring area that may need further inspection by an electrician, etc. moving forward. So here's just some quick examples of us out in the field doing some test and tagging. Obviously doing an appliance test on a grinder, doing some biomedical testing in a theatre environment, and doing thermal imaging, which as you can see we can pick up on the heat with non-contact issues within a server room or control panel. So you might be asking, why is this so important? Well, unfortunately, people can be stupid, as some of these failed photos will show you, just some of the stupid things and dangerous things that people will actually do with their electrical equipment just to make things work. And being of a Kiwi nature, we tend to try to have the old number 8 fencing wire repair mentality, and what they can actually do is just create an issue where we could overload systems, cause the ability to shock or harm, or sometimes even kill people. So it's very important that we actually know the limits of what the equipment we're using and how we can actually minimise the chances of any issues going forward. Now, although those previous slides were stuff we found on the internet, here's some prime examples of some issues we have out on the field whilst doing our job on a day-to-day basis. This yellow box is what we call a lifeguard, made by a company called Lifeguard. It's a 6-way power board. It's designed to be waterproof or be used in all weathers. And on top of the white box, the little white square with a grey see-through lid actually houses what we call an RCD, which is a residual current device. Now these are designed to actually trip, like a circuit breaker, but a little bit more involved, if anything was to happen, if a lead was to be cut or there was some issue within the appliance you're actually using. Now our test equipment can actually test these RCDs and put them through a fail system to actually make sure that they do trip, and the trip time on those is within 30 milliseconds, so it's a very, very short period of time, with the idea of actually making sure that if anything was to happen, it's not likely to cause an electric shock to the person using the appliance. Sadly, we were actually called to a site to do some checking of some electrical gear, and whilst we were there, the company had actually came out with this RCD. It had what we call a 15 amp plug, which had actually been chopped down so it would fit in a 10 amp plug. I won't get into that now, but whilst we were actually taking it out to get it repaired, we actually noticed that it actually had a bit of a sloshing sound inside. Now these units are designed for all weather, so they're designed to be used in construction and sites outside where obviously the idea is to keep things as safe as possible from the elements. But what we actually discovered when we actually opened this up was approximately about a litre or so of water that was actually inside the unit. We obviously had to open the unit up and draw that out, so it's actually not beer sitting in that container beside, it actually was the water inside. And what we actually discovered, that it was actually, we believed that it was actually dropped into a elevator shaft, which was at the time full of water. So the interesting thing here is that if someone had just picked this unit up and gone and used it, with all that water sitting inside, well, I guess you can just kind of imagine the end results and how tragic that could have very well been. Sadly, the most common thing we see out in the field is where the core wires, so that's the blue, brown, green and yellow core wires inside, have actually come away from the plug or been damaged, as you can see with the plug there in black. The sad thing is people see this and they go, oh, it'll be alright, or they'll wrap it up with insulation tape. Now the reality is insulation tape is not a approved way of sealing these back off, and the reason being is the insulation tape will still allow moisture to get in behind it. I've even actually come across plugs that have actually had exposed copper wire coming through those core wire insulations, and they were actually wrapped up in masking tape, and the masking tape was actually wet. So as I said, unfortunately humans can be stupid, and our recommendation to everybody whenever we see this out in the field is to educate your staff and say, look, if you see anything like this at all, just take it out of circulation, stop using it, send it away for a repair. Neither of these two could be repaired without actually having to replace the plugs. Now this would have to be one of my most scariest discoveries I've ever had. This was in a workshop environment. We'd been there previously. We do this one every 6 months. Whilst going around and checking the electrical equipment, we came across 3 extension leads that showed up as being faulty going through our testing unit. At the end of the day, we sort of went more into investigation of why they'd actually failed. This is 2 of them. As you can see here, this one here with the red arrows pointing to actually had the phase terminal connected to the wrong plug, and you can actually see that the plug actually shows you where the earth should have actually been. Equally, phase and neutral are incorrect as well. Same with the picture on the right. The earth has been connected up to the phase terminal, and the neutral has actually been connected down to earth, and obviously the phase is incorrectly wired as well. Now the situation here is, well, the interesting thing is the plug actually shows you where earth should be with a nice big E and a nice green dot, but someone, whoever did this repair, was either in a hurry or was very incompetent. The sad situation here is this could have actually killed someone. You know, at least given them a shock, but at worst could have killed someone. And the plug would have also come with some instructions to actually show you how to wire them up properly. Now, the situation in New Zealand is, in a workplace environment, we shouldn't be repairing any electrical gear ourselves. We should be calling in either an electrician to do something electrically, or a technician to be repairing an appliance. And we shouldn't be doing these ourselves. But I guess with Kiwi nature the way it is, and the number 8 fencing wire, and she'll be right, we can do it. We actually do open ourselves up to some major issues, and obviously some chances of major harm. With the advent of online shopping and being able to import equipment, sometimes a lot cheaper than what we can actually buy here in New Zealand, we're actually opening ourselves up to a major problem. Out in the field, we actually see a lot of appliances now being used, having to incorporate a travel adapter to make them fit into the New Zealand outlets. The reality is that it's actually illegal to use these sorts of equipment for permanent use in New Zealand, and with it not having the correct plug, it actually means that it is not actually an approved appliance to use within New Zealand. We actually see a lot of equipment being used now where people have actually put a travel adapter on and utilising them in their work environment, and in some cases some companies have actually even tested and tagged them, even though it is against the law. The reality is, when you actually use an appliance that needs a travel adapter, as I said, it's not actually been approved as an appliance. All electrical appliances in New Zealand have to go through a regulation of actually making sure that they are approved to use, and they actually do have a little stamp normally on the plug that actually shows that. And a lot of these units, because they don't have the New Zealand plug on them, or the standard what we call AU plug, that means that they're actually not authorised to be used in New Zealand. So if you actually have a fire or a major issue within your workplace and you're utilising these equipment, you may find that you won't actually have insurance. As a professional test and tag company, we recommend that companies follow the AS/NZS 3760 standard. This table shows that the intervals of which electrical equipment should actually be tested. Now, it does get a little bit confusing, but I'll break it down for you. So if you're in construction, if you're building commercial properties, residential properties, or a trade that is actually associated to help those trades out, so plumbers, electricians, of the like, then your equipment should be tested every 3 months. If you're in a manufacturing environment where you're assembly, you're making of equipment in a factory environment, then your equipment should be tested every 6 months. And then we move into a little bit more, so a staff cafeteria, your equipment, you know, the jugs, the microwaves, etc., should be tested every 12 months. In an office environment, things like laminators, shredders, heaters, lamps and laptops, phone chargers, they get tested for a 12-month period. and then equipment likes of monitors, computers, and as a company we do other equipment under the desk as well, multi-boards, etc. should be tested every 5 years. Now, bearing in mind monitors and computers are a very interesting situation. A lot of them will actually have a removable cord, so we call an IEC lead or a jug lead, can actually be removed from the back of a monitor or the back of a computer. If that's the situation, then that actually requires 2 tags. So the actual computer box itself is a separate item and the lead is a separate item. And as a company, we'll actually test both of those for 5 years. There are some companies out there that will only do those for 12 months. And in some aspects, I think that's a bit of a rip-off. Right, the big question, do I need to be tested and tagged? Well, that really depends on how and where you're working. But of course the reality is, actually, no you don't. Test and tag is not a legal requirement. What the standard states is that your electrical equipment should be checked and inspected on a regular intervals to make sure that it's fit for purpose and that the equipment is not faulty. Of course, if you're working in an environment like a construction site where they actually say, well, if you want to work for us as a subcontractor or as an employee, then your equipment needs to be tested and tagged. In which case then you need to comply with them and actually follow us through on their health and safety documentation and make sure your gear is tested and tagged. So why do we test and tag? Well, the reality is it's very simple, because we can actually see when it's tested and of course when it's due to be retested. But if you're in a small work environment, small office situation, you may want to just do something in-house, and the standard basically states that at bare minimum you should have something like a Excel spreadsheet which actually documents down all your electrical equipment in your workplace, and looking at it and having someone just checking it on a regular basis to make sure visually that it's okay. There's no nicks in the lead, there's no exposed core like I mentioned earlier on, and that your gear is fit for purpose. Now of course if something's not quite right, then the big recommendation is stop using it. Put it to one side, get it checked, get it sent out for repair, whatever, but just stop using it, because that's what's going to save lives in the long term. So why should you use MegaTest? Well, we're cost effective, we're a professional service, and we have qualified technicians. We give honest advice, but like this video clip, and we give also a full asset report. We're here to help. We're happy to take phone calls and just give you a bit of guidance, and of course we're happy to come in and give you a bit of a quick quote and give you a bit of an idea of how you can do it. We'll try to look at ways of minimising that cost. If I can suggest different ways of having things wired within your office with multi-boards using USB plugs rather than having to test phone charges all the time, we give that advice freely, because we believe that once you start working with MegaTest, you are part of our family, and we want that to continue on moving into the future. So give us a call, look us up on the internet, and let's have a chat, see if we can help. Thanks very much. Have a great day.